This video will look at complex ions, ligands and coordination number. So some of the definitions to start with. So a complex or a complex ion is a metal ion surrounded by ligands, and a ligand is a molecule or an ion, a species that forms a coordinate bond with a transition metal ion by donating a pair of electrons, so forming a coordinate bond with the metal ion. And the next phrase is that they can be monodentate, bidentate or multidentate. So if you think sort of dentate to do with teeth, so we can bite once, twice or several times onto a metal ion. Let's have a look at some monodentate ligands. So these are molecules or ions that are able to coordinate once to the central metal ion. And to be a ligand you need a lone pair or more than one lone pair. So water is an example of a monodentate ligand. So having a lone pair means it can form a coordinate bond from one of those lone pairs. Same idea with ammonia or with a chloride ion. And for a cyanide ion there's actually a lone pair on both the carbon and the nitrogen, but it's going to be far more likely that the coordinate bond is from the carbon rather than the nitrogen. Let's have a look at a couple of bidentate ligands. So these are ligands which are able to form two coordinate bonds with a central metal ion. The first one, 1,2-diaminoethane. Sometimes see this abbreviated just as EN. And you can perhaps see, if I draw it out like so, with the lone pairs on the nitrogen, we can see how this will be able to form two coordinate bonds to the metal ion. Let's have a look at an ethane diauate ion. Fairly similar in terms of the geometry to the one above, in terms of the number of bonds which separate those lone pairs. So there we are, we've got the lone pairs on the oxygens, and if we bring along our metal ion in a similar way, this can now form two coordinate bonds to the metal ion. In terms of the multidentate ligands that we need to know about, there's really just this one, which is the EDTA with a charge of 4-. We'd refer to this as a hexadentate ligand, as there are 6 atoms on this complex which is able to coordinate to the metal ion. So as we've seen in our other examples, we've got the lone pairs on the nitrogens, so that will give us 2, and in addition to that we have the 4 oxygens carrying the negative charge, so there's 6 atoms in this ion which are able to coordinate to one metal ion.